OFC 2025 and it's all about AI. At the Executive Forum, it was clear that we need high fiber density for two solutions, high capacity and ultra low latency. We are interviewing the right companies that can provide hollow-core fiber, multi-core fiber and high density fiber bundles. I'm here with Holly Hulse, the President and CEO of Lightera. Holly, thank you very much for having me. What does Lightera do in the field of photonics for AI?
Well, I'm glad you asked, and the comments that you just made are spot on with the work that we're doing. In Lightera, we've just come together as one new company. We've just announced our new brand, and what Lightera does is it brings together companies from around the world under the Furukawa Electric umbrella. These companies are actively involved in all of the things you discussed. We're doing development in hollow-core fiber with the biggest players in the world. We have multi-core fiber development for both terrestrial and undersea applications. And of course, we've been working for many years on higher and higher fiber density cables, up to 6912 commercialized now and working on levels beyond that. So we're very excited today to share some of that with you. And I would like to hand it over to our expert in-house on hollow-core fiber, David Knight.
Indeed, as Holly said, hollow-core fiber seems to be living the right years at OFC this year. What do you think that is?
I think the latest generation of modern, ultra-low-loss hollow-core fibers bring a lot of excitement to the industry as we open up new applications that bode very well for the future of our industry.
One thing is to manufacture hollow-core fiber, another thing is to splice it and to connectorize it. And you have solutions for the three things, right?
We do. We offer a complete ecosystem of hollow-core. We've been deploying live hollow-core links, carrying traffic since 2018. So we make a variety of hollow-core fibers, including very low-loss modern fibers, cable designs for inside and outside, connectivity, splicing solutions, and at the show, here today, we will be demonstrating a new version of the Fitel splicer designed to give even better performance for hollow-core cable splicing in the field.
So solving the problem of latency. Latency will be dramatically reduced with hollow-core fiber. For many years, we've been needing high volume demand to decrease the cost of hollow-core fibers. Now it's here. There's many manufacturers of hollow-core fibers at OFC this year. What makes Lightera difference?
I think our experience that we have so many years of actual practical experience, the cabling trials that we have done, the experience we have with all of our deployments with our customers since 2018 around the world, we offer the complete ecosystem.
David, Holly said that you bring the hollow-core fiber, but also multi-core and fiber bundles. Can you introduce us to some of your colleagues who can walk us through the other solutions?
Yeah, I'd like to introduce you to David DiGiovanni, our CTO.
I think what is new is the market acceptance and the impending adoption. People have been working on multi-core fiber for many years. Right? We've come to this conference for the last 10 years, and it's always been a very hot topic. But finally, the applications are starting to get more serious as we see the need for increased fiber density in a cable and the extended bandwidth is starting to run into constraints on space. And now it's becoming real.
A few years ago, multi-core fiber saw the light with shape sensing applications, but it was always the doubt whether price could be a challenge to go to other longer range telecommunications. What has happened?
It's just a continual evolution. People have started to explore it on the application space. It's driven the need for more and more fiber as for R&D and for test and measurement. And so the processing development needed for scaling it up and therefore driving costs down has continued to evolve.
CPO is here to stay. Co-packaged optics is here to stay. The density of fibers coming into CPO module is totally crazy. How many cores do you think you can put in a hollow-core fiber? In a multi-core fiber.
In a multi-core fiber, it depends on the details of the design, how tightly you need to bend it, and how much space you have in the element. So in a CPO package, you're constrained in space, so you have to bend it very tightly. So you don't want to increase the fiber diameter, yet you're going a short distance, so you can pack your cores in more tightly. So certainly more than 4. Not sure if you're going to need more than 8, 12. People have done 16 and higher.
We talk about hollow-core fiber and multi-core fiber. What else did you bring to OFC 2025?
We have a lot of things here at our booth. We're doing
Would you walk us through it?
Sure.
Yes.
This is essentially a standard fiber, so an all-wave flex type fiber that has enhanced backscattering. This increases the signal coming back to your interrogator to measure an acoustic field in the environment of the fiber or cable. So with a 10 dB enhancement in acoustic sensitivity, you can literally hear more that's happening in the vicinity of the fiber.
You do an attenuation of 0.3 dBs
Yes.
per kilometer. What new applications are you seeing that are demanding DAS at this moment?
Two things. Number one, this was developed initially for an oil and gas application for downhole, where you're trying to sense seismic activity to improve the yield of a well, for example. That has now migrated by improving the fiber to a telecom type application where you can use it in a smart city application to monitor traffic flow, to monitor the health of your civil structure, to monitor bridges.
Okay, what else did you bring us?
You talked about Lightera,
Yeah.
and Holly mentioned the assembly of multiple divisions of the Furukawa group. One of those is our sister in Brazil, where they have developed technology for monitoring the health of a pond system. Box that hangs from an aerial distribution. It's sensing the health of the signal in real time, so that you can detect a fault or an impending fault before some crisis evolves in this unit goes down.
When it comes to real-time monitoring on network infrastructure, are there different standards in different countries?
And that's something we have to deal with. And where do we try to harmonize, and come up with a global standard? Where do we need to customize for the local environment?
David, this is a lot of fun. What else did you bring?
So this is the splicer work that David Knight talked about. Part of the ecosystem that we're bringing to bear on both the hollow core and the multi-core. So these splicers have been developed now to include end-face monitoring, so we could see the quality of the cleave of the fiber. That's particularly important for hollow core. It also has a rotational alignment now with the fast algorithm, so we can actually detect the orientation of the fiber, which obviously is important for matching up multi-core fiber, as well as the hollow core fiber.
It is clear that the challenge for actually doing the splicing on a hollow core and multi-core fiber is multiplying. It's also multiplying the time for the splice.
A little bit because of that monitoring. But it's essentially the same kind of splicer. In our case, we're using a ring of fire where we have basically 3 electrodes creating a plasma. And by monitoring and maintaining the plasma arc, it has essentially the same time needed to do the splice, but the diagnostics for rotational alignment, that does add more time.
The data centers has been really the big thing, and I know you're working a lot on that. What do you want to evolve? What do you want to bring to OFC 2026?
Let me show you some of the stuff that's happening here. This comes from our Furukawa partner in Fitel. Fitel is not coming with Lightera, but part of the Furukawa alignment. And is, I guess we just want to show one thing. It's the high density that would be needed either in a CPO package or a data center application, right? So increasing the density, reducing the size, improving the connectivity, since every GPU needs to be connected somehow to every other GPU, right? And if you've got tens of thousands of GPUs, you need a lot of density. So we're developing new technology that will enable that in a very cost-effective manufacturing cost-effective way.
Still today, when you look at the way that Broadcom does the fiber assembly into the co-packaged optics, it's a very manual process because it's very difficult to align such amount of fibers. What solutions can we do for this?
That has been a long-standing question for 30 years. Right, there was a calculation done by JDSU, if you remember them.
Yes.
They said that, if you extrapolate the bandwidth demand, you're going to have 10% of the world population doing manual assignment of optical components. That has to change. And I think the solution is going to be integration. I don't know if it's going to be an automation.
Okay, and it's time for me to go to the other members. Tell me something exciting before I leave.
I think one of the things that's most exciting, or exciting to me, is this is not just about telecommunications where you're helping people connect to each other. It's about the growth of AI and how that will have a societal impact. But we're also seeing the adoption of photonics now for things like security and sensing to improve quality of life. We're seeing penetration into the medical space. We're seeing it into the financial space. We're seeing it into defense, right? All aspects of society are being impacted by photonics. Right? I see that happening at this conference with the growth of sensing that suddenly become an important part of the OFC, right? It's not about fiber communication, right? It's about how people can use or how society can benefit from optics.
David, thank you so much for showing me everything. Introduce me to the people in your team. The world looks really exciting because of the fiber that you bring to the market. Thank you so much.
Yeah, well, thank you.
Thank you.
All right, take care.